Hello. So now we go to parallel circuit. Okay. So in parallel circuit connection, okay, the total resistance is 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus, okay, so on and so forth. Okay, so meaning the total resistance is equals to 1 over 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. Okay, then to get the total current, okay, to solve for the total current, it must be I1 plus I2 plus I3. So it must be the total current in each nodes. And then to get the voltage or the voltage drop of each resistor. Okay, so actually it's just the total voltage is equals to the V1 and equals to V2 equals to V3. So this is just for the simple simple parallel circuit sample. So for example, on this circuit, okay, so we have here, let's use the same resistor values as we have used earlier in our series circuit connection example. So we have here the R1, the R2, and the R3. And our values would be 10 ohms, 20 ohms, and 30 ohms. Okay, and our source is 12 volts, okay, positive and negative. Alright, so now let's first solve for the total resistance. Okay, the total resistance is equals to 1 over 1 over 10 ohms plus 1 over 20 ohms plus 1 over 30 ohms. With this, we get the value of 5.45 approximately, okay, 5.45 ohms. So this is the total resistance value. Then next, let's determine the voltage at resistor 1. So here the V1, the V2, and the V3. Okay, so knowingly, our total voltage is known to be, okay, our source is known to be 12 volts. Therefore, as per concept, okay, so our V1 is also equal to 12 volts, right? V2 and it's also equal to V. So they have the same potential, okay, here, here, and here. And now, let's solve for the total current. Okay, solve for the total current. So before determining the total current, let us first determine the current on each resistors. Okay, so here we have here points. So this is what we call the nodes. Okay, so the current passing through here, okay, from the main current, right? The IT, then how much current passes through in here, and in here. So let's first solve for the I1. So knowingly, okay, I1 is just, recalling the Ohm's law, V is equals to IR. So I1 is just V1 over R1. So our V1 here is also 12 volts. So 12 volts over R1, 10 ohms. Okay, the answer is 1.2 amperes. Okay, now we solve for I2. V2 is equals to I2 is equals to V2 over R2, so 12 volts over 20 ohms. The value is 0.6 amperes, and for I3, it's V3 over R3. Alright, so it's just 12 volts over 30 ohms, and that is 0.4 amperes. Therefore, our IT is 2.2 amperes. So that is the value of our total current on this circuit. Alright, so up next is series and parallel combination of circuit. Thank you.